Now you can hear me. Thank you. Wow. If no one had been here, we would have done the whole office hours muted, which I have done once before. But I was making some cool videos, which I've been working on that in the background. Got a big presentation tonight. Trying to make some cool, fun videos. Scholar, you get some 5,000 points for that right there. Totally was muted. We would have done the whole office hours muted, but I had to mute the microphone. I wish, boom, welcome, Brian. I wish I could, I can kind of show you. I have to get it fixed up. Yeah, I'll show some, we might have some new fun stuff. Ava, good to see you there too. Which one should we do? What homework assignment should we do? They thought it was your audio. Sorry, Dee in the chat. What's up? Another 5,000 for Dee right there. But good to see everybody. What chapter 7 quiz question should we do? Chapter 8 is also due. No, chapter 8's due way later. Chapter 8 is due after. It's due after. What, for Brian? No way. Thank you, Dee. Just for you giving me points. Here's some more points for you. Students love that. Okay, we did a bunch of these yesterday. I'm going to go for like 40 minutes or so. Try to get a bunch done here. Okay. Let's take a look. This chapter is... Which questions are you on? Let's go here to the main screen. Which questions are you working on? Which questions are you working on? We got 18 hours. New York City data. Let's do it. Starts out New York City data. Here we are. Okay. So your questions are always in a different number than mine because I see all the questions. I see every single question. So I can see them all questions. And so let me know the start of your question, like New York City data right there. And then I'll find it. So that's question 15 for me because I see every single one of them. So just give me the first few words of the question. So Stat 201, Chapter 7 quiz. And this is the New York City data. So this question right here, let's take a look at what we got going on with it. The way they phrase this is a bit weird, and we really never ask it this way on the test. First off, what are the variables in the units in the regression? We are trying to predict from this regression daily water consumption in millions of gallons per capita. We're doing it from the years. You can see the model. Water consumption is going down per capita, and so it's going to be water consumption in millions of gallons per person. That is going to be, what are the variables in the units? Water consumption in millions of gallons per person. So specific. What is the units of the slope? It's going to be for each additional year, we see water consumption in millions of gallons per person decrease. So, or millions of gallons per person? Water consumption per capita. And the table shows daily water consumption per capita in gallons. It is per capita means per person. I'm pretty sure it's this one. What are the units of the slope? It's going to be millions of gallons per year, as in for each additional year, we see the amount of water usage going down. Do you see, who follows me on this? Ava and Scholar, does this make sense? Like for each additional year, we see the water consumption decreasing a little bit non-linearly at the end. Now, the last part right here, it wants us to find the correlation. Now, before we answer this, the correlation must be what? Finish my sentence by looking at this visually. The correlation must be what? The correlation must be what? Just finish my sentence. And I'm talking about this. Must be negative, exactly. So what you do is you take r squared and you square root it. So all we do is take r squared of 0.928 found right there and square root it, and then we make sure we know it's negative. So that's got it. Just make sure to do the negative version, and we should be good. A little worried about the first one, and I'm right, though. We did it. One problem down. What's the next problem we're doing? Just keep those problems coming, or you can mention any problem at any time. Just give me the first 3 words of the problem. We might need the Regression Solver Pro, so go check out the Regression Solver Pro if you don't have it yet. That is found in the modules. Because this is, we right here have r squared. Good question right there, Ava. So the quantity given in the problem is r squared, which is correlation squared. It's no longer interpreted as correlation, but this is r squared, and we are going to square root it to get r. But once you get r right here, r can be negative or positive because r also gives you the direction. So r has direction, where r squared is a percent of variation in y explained by the variation in x. So does that make sense? There's a difference. Is r the same as tan theta? I don't know. That's a good. Find that out for me. I don't do much tan theta. That sounds like trigonometry. But good question. And there's a few of these right here, Skylar. So we'll grab this one. Good question, Didi, right there. I do not know the answer to that. So the manager at the bookstore question. Tell me if I have the right one. So I need a yes, no on this. Do I have the right manager at a bookstore question? I'm gonna draw some more questions. So is it this one right here? Is it this one, Skylar? And just say yes or no in the chat. There are a few manager at a bookstore questions. Is it this question? Yes or no? Just yes or no. Is this the right manager at a book? Yes, you believe so. Now for this one, you need the Regression Solver Pro. The Regression Solver Pro is going to make life way easier. For some reason, I am kicked out of. Okay. I think it makes me relog into Canvas like a billion times. Went away from Canvas. Log into Canvas here. Okay. Log into Canvas. No, use the Regression Solver Pro. Regression Solver Pro is the way to go. That's what we say. So the Regression Solver Pro can be found over here under the modules. Go to the modules right here. And under the modules, under Chapter 7, you will see the Regression Solver Pro. Go ahead and download said Regression Solver. So we're just downloading the Regression Solver Pro in the background. Go ahead and open it up, and we'll have it going over here. I'm going to keep this over on the side for when I need to reference. Download the Regression Solver Pro. And I'm going to show it here in 1 second. Here is the Regression Solver Pro. Now, there's 2 spots on the Regression Solver Pro. Got to have Pro on it. That way you know it's good. And you have up here, you can enter in things like the correlation, the standard deviation of y, the standard deviation of x, the mean of x, the mean of y, and it'll solve for you the intercept and the slope. You can also enter in the data over here, and then it'll solve for you for the slope, the intercept, and you can also use the bottom. Oh, 9,000. We need to add 9,000 on that. And then you can use this to solve out certain values. Notice that the slope is negative 0.7, so if I enter in here 2, it's going to go down to about 4.8. How did I know that? Because you're subtracting minus 0.7 minus 0.7. If I enter in 4, we have to go down another, or let's just enter in 3. Then it'll be like 4.1. Because every time I go up by 1, it subtracts another. No, you're fine. It subtracts another one. So if I enter in another, like to 4, as the slope is negative 0.7, it's going to go down to about 3.5 or so. These are around to 3.5. You enter in another one. See, even we go off topic around here. Another one. This may be a dumb question, but if we can't solve it on the exam, so we wouldn't, things that the solver does, we don't really expect you to do. We do expect you to know how to plug in numbers to solve. Like we give you a regression equation. Like imagine I give you, like if I said, solve for somebody's exam score. Score on the exam is equal to 40 plus 5 times hours study. Somebody studies for 4 hours. What do you expect their exam score to be? This is kind of mean. But if someone studied for 4 hours, what would you do? So what would be the predicted exam score if someone studies for 4 hours? This would be a hard exam. It's like an organic chemistry. Exactly, Skylar. So that's the kind of mathematics we expect you to do. And then here's one last one. So you predict their score predicted, and we should have put a little hat for predicted, is 60. They actually score a 90. So their actual score is a 90. You could call it Y. What is their residual? What is their residual? And the way it would look is the individual would be up here. So what is their residual? 30 plus, yes, exactly. They're 30 points higher than predicted because this is the predicted, this is the actual. This is the math we expect you to do, that residual equals actual minus predicted. So that's the kind of math we expect. Does that make sense, Skylar? We don't expect you to do the equations to get the slope and intercept from scratch, which can be found underneath these calculation areas. So that kind of helps you understand, like, what do we expect on the test? We expect you to know y hat equals b0 plus b1x. We expect you to know, and we do give you the equations, that E, which is residual, equals actual minus predicted. Good stuff. So now let's go to the question and solve it. Now that we know what we need to know, you're going to go right here and grab the data. And with the data right here, you see you get the summary statistics and you get the data itself. I like using the data itself simply click on this and go copy to clipboard. Now hit Control-C or Command-C. Hit done and done. Go back to your Excel spreadsheet. Click anywhere inside of it and paste the data. Now you have to know what the Y variable is and the X. The Y variable is called the variable of interest. We're interested in money. So hold Shift and click the bottom cell and hit Control-C or Command-C. Now, click the first cell, not the Y, but the first yellow cell and paste the data. Now, grab the X variable, hold Shift, hit Control-C or Command-C to copy, and then click 15, or right there, where the first cell to copy in is, and then paste. Make sure you've not pasted over the X and the Y, because this is where the calculations will occur. You can see we've labeled everything for you, the intercept, which is B0, the slope. We don't need the correlation, but we have it if we want it. And we can even check the problem by looking back at these right here to see if we have the right values. So let's go ahead and take a look. We'll put it side by side for us. Where is it? I lost it. There it is. No, I used to do side by side the other way. So a question like this wouldn't, parts of it would be, let's see which parts of it. Well, so we have here the slope, which is 0.89, and it wants to 3 decimals, 0.893. Now, we would ask you to interpret the slope. The slope is, for each 1 unit increase in X, we expect Y to increase or decrease by B1 on average. And if you say slope in the chat, MuBot's going to tell you what the slope is. So when you think about this, for each additional worker, because that's what X is, we expect sales to increase, because there's a positive slope, by 0.893 thousandths of dollars on average. So it means an increase in this much money. So in sales, it means that on average, an additional increase in this is associated with each salesperson working. So for each additional salesperson, we expect sales to increase by this on average. What does the intercept mean? The intercept is 8.681. What does the intercept mean? Who can tell us what the intercept means? Who knows? What's the intercept mean? Any thoughts on the intercept? When X is equal to 0, we expect Y to equal B0. So remember, we always do like the, what does it mean in context? So great work right there, Scout. We're 30 some points. So when X is equal to 0, so what's X? It's the number of workers. Remember, we have workers over here, 2 workers, 4 workers, 5 workers. So when no one's working at the store, we expect to make $8,681. It's like, well, that doesn't make sense. If no one's working, we're not going to make any money. So when X is equal to 0, expect Y to equal B0. So this means on average, the sales will be equal to this by this. Nope. It means on average, no. It means on average, the expected sales with 0 people working. I think this is it. That sounds about right. So now we have to write the equation. This is something you would have to do if you have to find the slope and the intercept. So the intercept is this, B0, and the slope is this. It is positive. Make sure right there. If there's 17 people working, what do you predict? Well, here's the really awesome thing about this. Since we're using the Regression Solver Pro 9000, you can go in here and just enter 17, and it'll solve it for you. Now, these numbers are not perfect because we've rounded some decimals. We can actually just take 17, though, and plug it into the problem, 17, and multiply by the slope. So this would be expected. Once again, the Solver Pro can do this, but you are expected to be able to plug a value into a regression equation and get the predicted value. Notice it is a tiny bit different, but if you grab this number here from the solver, it will work. So this is an expected thing we expect you to do, even though the solver can do it. Now also, it is asking you to turn this into thousands of dollars. So that'd be 23,000 right there. And it wants the nearest $10, so we're gonna round up to 60 right there. So now, the actual sales are this. In notation, what is the notation for actual? So just really briefly, this is another expected thing to do. What is the notation for actual in notation? I'll give you some hints. Is it that? Is it that? Is it that? Is it this? What is the notation for actual? Think actual minus predicted, residual, equals actual minus predicted. Because we're trying to find residual. Well, close. Close, Scholar, close. Y hat is predicted. So when you do the regression equation, it's Y hat equals B0 plus B1x. And so that is the predicted, which is right there. and then the actual is y. So the dots are the actuals, and the line is the prediction. And the residual is the e, which is the difference. So when it wants the difference right here, the difference is residual equals actual minus predicted. So 1,140 is equal to actual 25,000 minus 23860. So that should be it right there. The math should work out. Residual equals actual minus predicted, 1,140. Now here's where we have to be careful. Slow down. This question changes. The way the model looks is this. The point is here. It's at 25,000. And the prediction is down here at 23,860. So that's where if you were to trace and predict. So that's the predicted. The model has what? So the residual is positive because it's above the model. It's a positive residual. The model has what? Under or overestimated. Just type under or over in the chat. The model has under or overestimated it because the model is the line. So the model has what in it? The residual is positive because it's there. That was our 1,140. It's underestimated. Great job, Megan, right there. It's underestimated. The model has underestimated it. You are right. And we should get that hundo. Let's hope we did it. Check answers. 100! Great job. Let's do another question right here. What question should we do next? Drop more questions. We got time to go to right around 5-ish. Which one should we do next? What should we do? And I will say this, shout outs to those people using videos from previous semesters. I've got a video going over pretty much every problem, but I want to help you solve the ones right here. If you're here live right now doing some office hours. And then we'll talk, you can ask questions like, what am I supposed to know for the test? That's a really good question. So, what do we got? A data set on 91 roller coasters. Let's go find it. I think I did that one lately. Look, I found it right away. Oh, Skylar, this is going to be a tricky one. I think this one I actually get wrong every once in a while, so we've got to be very careful. That's your last one. Well, follow along and don't hit enter yet because every once in a while, Brian gets something wrong. And this could be one of those questions because I know I have made mistakes on this one. So we're going to try not to second guess ourselves. I think it's rides that have steeper declines or faster. I think this one gets me. You ready? Let's get that 100, Skylar. Okay. So in this problem, we're looking at the Tower of Terror. And it's the drop height and how... Wait. On the coaster of Tower of Terror is unusual for having a large drop but a short ride. Okay, wait. So they're saying it's unusual because they're saying larger drop, shorter ride. Oh, because the Tower of Terror is just like, wah, and then you're done. So usually larger drop means wider ride, like more of a drop, because this one's unusual, larger drop, shorter ride, so they're removing out the outlier because it's kind of a different thing. It's a coaster? I don't think it's a coaster. It's a drop ride. So usually, other than this one, larger drop means what? This one is larger drop, shorter ride, usually larger drop, wider. Because this one breaks the trend. It's an outlier. This one is larger drop, shorter ride, usually larger drop, wider. I think you see it, right? If it's unusual, then the general trend is going to be larger drop, longer ride. Exactly. Let me go to top live chat. Okay. We're trying to predict how long the ride lasts. So the predictor variable is, and I hate that they say it, the predictor. This means the explanatory. So we're doing, does the drop in feet per second explain the response? The response is what we like to talk about. We call it the response variable of interest because you think when you say why, you want a response. Let's go remember the response is the why. Like you say to your parents, why? And then they respond to you. So this is going to be the duration of the ride in units of seconds. This is the one I get wrong. It's going to be how long does it last per foot of drop? Yeah. Because for each additional foot we drop, the ride might last longer. Okay, got it. And since they said it breaks the trend, remember it said originally there was the one that broke the trend with the inverse relationship. Usually longer drops, longer ride. It's going to be positive because coasters with bigger drops probably provide a longer ride. Let's check it. Is it this one? It wasn't that one. Slope is probably going to be positive. Coasters with bigger drops probably provide longer rides. The predictor variable is drop in... This should be right. Oh, it is this one? Well, the drop's just in feet. I don't know why I put... How many feet did it drop?
Wow.
I was so concerned about the middle part because I know I've gotten the middle part wrong before. And other than the Tower of Terror, it's a positive relationship. Gosh, this question is the bane of my existence. But I do agree, I did make an error. It's one of those Brian errors that just happens every once in a while. Just your brain says, wait, what? And it's dropping units of feet. Like, how many feet did it drop? But then when we think about the slope, it's for how many seconds per foot, like how much longer the ride will drop. So it goes to, what do you want to understand about the coaster? So when you go to an amusement park, you usually want to say, like, how long does this ride last? So at an amusement park, the length of the ride might be of interest to the consumer. Since the length of the ride, how long coasters last, especially if you're running an amusement park, like how long are people on this ride for, it's probably the variable we're most interested in. And the drop would explain how long the ride lasts. The question could do probably a better job. I don't know if there's any wording that makes it very explicit that the Y variable of interest is going to be, oh, look, actually it is up here. We are trying to predict duration. So predicting duration, if you're predicting it, you predict Y. So it is up there. Also, just theoretically, like, a lot of people might care about, you could say, well, what if I care about how big the drop is? Then that would make that the Y variable of interest. Yeah. In some sense, it is, we don't like the cause word around here. Mubot will actually freak out if you say cause. Mubot will get a little bit mad. He might even call you out in the chat. He might be like, you say cause or prove. Mubot gets mad at those words. We would say drop is associated, highly associated. I see, look at Mubot getting mad at me. We'd say drop is highly associated. And you're fine, Skylar, with 30 some points. We would say drop is highly associated or related to. Drop gives you a lot of information about how long a ride lasts. Let's try to do at least 2 more. What should we do next? What should we do? Drop a few more. Chapter 7. We'll do some big office hours tomorrow. I think this one's due tonight, right? Is it due tonight? Canvas. Yeah, let's do Canvas content. We've done a lot of this quiz. Let's do the Canvas content. And then we can tell people, oh my gosh, I'm clicking the thing over there. The table shows the live burst. I think we did that one yesterday. See if you have one more, Skylar. We did that one yesterday, and I might actually link you that video right here real quick. We did that one yesterday because I think we did the Canvas content. And I'm going to link you the live burst one from yesterday. The table shows the live burst. Here's yesterday's video. Table shows the live burst. And I'll link you the video right there. So there's the timestamp for yesterday. Let's knock out the Canvas content. And Skylar and Megan and Dee Dee and Ava, thank you everyone for being here. Always good to see you. And I think that'll if we do the Canvas content, we've done all the work for this week. We've done the homework. I gotta tell people, like, we've done the work. Okay, you ready? Oh, no worries. Okay, I think this might be one of our last things. Let's mark the Canvas content. So if you get this done, and Canvas content. I'm gonna put it in the title so people are like, ooh, he did the Canvas content. Okay. Where is it? 27. 4-3. Stat 201. Okay. Chapters 7 and 8, Canvas content. Both these chapters are basically on regression. Now, when you think about a residual, it's how much the model misses by. And we did this one a lot in class. We practiced the heck out of this. Almost like I try to practice things that I know you'll be quizzed on. Maybe on now or the test. So when you look at this right here, residual is the formula. Residual equals actual minus predicted. So the only 2 answers here are going to be actual and predicted. Those are the only 2 ones. A residual can be positive or negative, and the negative residual zone is if the point is below the line, and the positive is if it's above the line. The line gives the predictions. So the prediction is the line. And the actuals are the dots. Dots. So if a residual is positive, does that make sense? The actual is larger. Because if residual is negative, the predicted would be higher. As in, do you see this blue right here? If you're in the negative zone below the line, you have a negative residual. So this would be like -5, -10. I'm just making it up. Like this one's twice as far below. So it would be like 5, that'd be 10, that'd be 15. How far above the line is the residual? And if it's above, it's positive. So if the residual is positive, which we see right here, then it has to be that it is above the line. The actual is higher. So that's kind of right there. If you know the value of r squared to find correlation, what do? And I know there's answers, but let's think about it. R squared is literally correlation squared. So when you have the value of r squared, it is r squared. But here's the problem we run into. Can anyone in chat, if r squared is equal to 0.64, what is the value of r? So what is the value of r for this plot over here? I'm asking, what is the value of r? Who knows what the value of r is? So for that plot over there that I've drawn, who knows in chat what the value of r is? Does anyone know? What is the value of r? R. So it's r squared, right? Well, I mean, r squared is not r, but wait a minute, we already know r squared. So what's the value of r? I'll see if anyone answers, and I'll answer my own question. Oh, I want to throw some 5,000 points. Correct, Megan. You're right. It's either plus or minus 0.8. And you are right square rooted, but which one is it? Is it positive 0.8 or negative 0.8, and why? You're right. It could be positive or negative when you square root it. You just square root it. You go square root and bring it on there. So which one is it? It is the negative because the plot goes down. Does that make sense? So it is negative. So what you do is you square root it and you look at the direction. So because the graph goes down, it is negative. That's the direction. So square root the value, take the square root and check the direction. Look at what we're given right here. It says if the residual is this and the observed is this, what is the predicted value? This is where Leo comes in
Notation,
and we know our notation. So notation is key to this problem right here because it says the residual, which is E, is equal to that. The observed, which is Y, what is the predicted value? So 1.1, well, we can write it E equals actual minus predicted. And now we can plug in the values. 1.1 equals 16.6 minus and then y hat. So you can solve this out. But when you solve it out, you are going to get, you just subtract from both sides and do the negative. It's going to be 15.5. And if you look, this does make it so there's a difference here of 1.1. And so just algebra it out. So algebra it out. And you should have that the equation solves and works. So the predicted would be 15.5. Also think if it's positive, that means it's above the line by this much. So if you're at the dot, you'd want to go down to the line because if it's a positive residual, the actual is higher. We covered that earlier. Find the predicted value from this equation. So we're just using the model to make predictions. And what you should do is you should immediately write out the regression model with this. So predicted value of y is equal to b0 plus b1x. X is this value right here. We're just simply plugging in the values we're given. What? Dude, Skylar, I'm hitting every point. Was that on the quiz or the homework? Skylar, you're doing great. I love it. That's what I like hearing. I tell people just start these things early and try. And if you run into problems, just let me know. Great job, Skylar, man. Shout out to you right there. Hard work pays off. I promise you. Like, quizzes can be tricky. Just plug 7 in. Boop. And Skylar just racking up all those points today. And all we do is plug 7 in. 7 times 3 plus, really? 7 times 3 plus 12, 33. Oh, yeah. And this one's not bad either, if you notice. And then if you add all the residuals together, will it sum to 0? The answer is yes. The residuals are points that tell us how far we missed by, and they go around the line. Some of them are positive, and some of them are negative, and the line cuts through the middle of the data, and because of that, if you add up all the residuals, they will add up to 0 because they cut through the middle of the data. Well, I'm gonna head off. We got a lot of videos. Let's submit. Make sure we got 100. I'll do one last speed run of this. I got 100, right? I feel so bad if I didn't get 100. I've done a lot of questions. Oh, we did this one. Take the square root and check the direction. Ooh. Is this r squared? Where's the r squared at? Oh, look, there's the r squared. 0.03. Where's the 3.23% of the variation in y explained by the variation in x? B1 is the coefficient right here. 0.733. We did this 0.77 right there. So that's the coefficient of the x variable. And I want to highlight this one real quick. You got this, Skylar. Congrats, man. In this output right here, you're given a lot of things, but here's the things you need to know. R squared is the percent of variation in y explained by the variation in x. You kind of need to know R. That's correlation. You need to know the B0 or B0, B1, respectively. So this is R squared. This is B0. This is B1. And you also need to know the p-value right there, which is statistical significance of the model. This model is not statistically significant because the slope of the x variable is greater than 0.05. And the intercept is 230 right there. So when age is equal to 0, that does not make sense. It's an illogical intercept. For each additional year, we expect the runner to take 0.77 longer to finish. If the residual is this and the observed is this, what is the predicted value? So that means we are below the line because of negative residual. So we need to go back up to the predicted line. Adding together all the residuals out to 0, that is true. If the correlation is this, what is the r squared? Who's got this? Last question of the day. If the correlation is 0.5, what is the r squared? If the correlation is 0.5, what is the r squared? If the correlation is 0.5, what is the r squared? Who knows what the r squared is? Because correlations are... So you take r and square it. So all you have to know here is you got it, Megan. Megan, did you get that 100? I hope you can say it or not, but I hope you got 100. We might have done all the versions, but I saw that tricky. It wasn't really tricky, but if the residual is this and the observed is so we're above the line, because a positive residual means you're above the line, so we have to go back down to the predicted. Residual is positive, the actual is larger, and then we got this one again. So we should, I hope people have hundreds on this. I want everyone to get hundreds. That's kind of my goal. For people to get hundreds and know the material. We're getting a lot of repeat questions now. With that, we're going to wish everyone an amazing evening. We will be back tomorrow, so we should do some Chapter 8 tomorrow. Might be slow tomorrow, who knows. But we're also going to have a special guest here tomorrow. Check it out. Bye from everyone. Bye!